In the modern world, computation is infrastructure. Server farms run the global economy, and the physical silicon inside these racks dictates who holds power. For 3 decades, that power belonged almost entirely to one company. This chart shows the stark financial trajectory of the semiconductor industry over the last 2 decades. On the left, in the year 2000, Intel hit a peak of roughly $495 billion in market capitalization. Their logo was on 80% of all personal computers. But looking at the right side, by 2024, NVIDIA's valuation rockets past $3 trillion. In November of that same year, Intel was entirely removed from the Dow Jones Industrial Average to make room for them. The fallout has been severe. Across 2024 and 2025, Intel's stock shed over half its value. The company eliminated more than 25,000 jobs, cutting roughly 20% of a workforce that spent their careers building the internet's architecture. An implosion of this magnitude does not happen overnight. It is the result of a slow, systemic degradation. And if we trace the timeline back, the entire collapse of this computing empire can be linked to a single, specific business negotiation. Keeping a monopoly is a fragile, active process. When a market leader stops fighting for its position and starts assuming its own inevitability, the foundation is already cracking. We have to go back to 2006. Apple was working on a secret project and needed a processor for a new pocket-sized computer. They brought the proposal to Intel's CEO at the time, Paul Otellini. Otellini and his team ran the numbers. According to their historical forecasting models, Apple was asking for a price point below what it would cost Intel to manufacture the silicon. The spreadsheets also predicted that the total volume of these devices sold would be low. Based on the math in front of him, Otellini passed on the deal. 6 months later, Apple released the original iPhone. It ran on a mobile chip manufactured by Samsung. In the years that followed, Apple sold over 2 billion of these devices, creating the largest semiconductor market in human history. Intel produced exactly 0 chips for them. Evaluating a completely untested category of human technology using data from past successes creates a massive blind spot. Historical spreadsheets cannot model a future that has not been invented yet. Because Intel refused the mobile market, Apple eventually took its massive and growing order volume to an external foundry in Taiwan, TSMC. To understand why this matters, look at this diagram showing the mechanical engine of the semiconductor industry. Massive production volume guarantees cash flow. That cash flow funds the massive research and development budget required to shrink transistors further. That research yields manufacturing supremacy, which then attracts more volume. When the volume of the smartphone market shifted to TSMC, so did the cash flow. Intel's engine was suddenly deprived of the fuel it needed to fund its next generation of factories. TSMC used that mobile revenue to subsidize their investment in extreme ultraviolet lithography, or EUV. These highly complex machines, built by the Dutch company ASML, use incredibly short wavelengths of light to etch transistors at microscopic, sub-10 nanometer scales. Inside Intel, CEO Brian Krzanich and his engineering teams looked at EUV and concluded it would be too difficult and unreliable to work at scale. They dismissed it, opting to stretch older legacy manufacturing methods to the absolute limit. It failed. By 2017, TSMC had successfully mass-produced 7-nanometer chips. Intel was stuck on 14. Technological superiority is not an inherited trait. When a corporation assumes its historical methods cannot be beaten, it hands its competitors the exact tools needed to overtake it. The consequences quickly spilled over into Intel's core markets. AMD, a competitor that Intel had easily outperformed for decades, spun off its own factories and outsourced its manufacturing to TSMC. Leveraging TSMC's superior 7-nanometer process, AMD launched the Ryzen processor architecture. It matched and frequently beat Intel's desktop performance. Then, in late 2020, Apple severed its remaining ties with Intel. They transitioned their entire Mac lineup away from Intel's processors to their own in-house M1 chips, again manufactured by TSMC. The M1 ran cooler, faster, and far more efficiently than the premium laptop silicon Intel had been providing. The cascade hit the public markets on July 23, 2020. Intel admitted to shareholders that their 7-nanometer manufacturing process was running over a year behind schedule. Their stock dropped by more than 16% in a single day, as Wall Street realized the manufacturing advantage was gone. Missing the smartphone explosion set off a chain reaction. The failure to secure mobile volume weakened the manufacturing division, and that specific weakness allowed competitors to dismantle Intel's grip on both servers and premium laptops. While Intel spent the decade struggling to fix its manufacturing delays under a series of finance-focused executives, a different competitor was building a parallel computing platform. Under founder Jensen Huang, NVIDIA spent 10 years quietly refining its GPU architecture and a software ecosystem called CUDA. NVIDIA correctly identified that artificial intelligence models would require massive parallel processing power. By the time the AI boom arrived, NVIDIA had already established the default software tools used by nearly every major researcher on Earth, allowing them to capture an estimated 80% of the AI chip market. The financial divergence is stark. In fiscal year 2025, NVIDIA reported over $60 billion in free cash flow, selling AI accelerators with nearly 80% gross margins. Over that exact same period, Intel's margins collapsed to the low 40s. Prioritizing quarterly margin targets and stock buybacks over difficult, decade-long engineering projects leaves a technology company completely blind to the next computing paradigm. Intel attempted to right the ship in 2021 by bringing back engineering veteran Pat Gelsinger as CEO. He launched IDM 2.0, a massive strategy to build new factories and open Intel's foundries to external customers. But a strategic announcement could not reverse 20 years of technical stagnation. By late 2024, the board forced Gelsinger into retirement. Respected industry veteran Lip-Bu Tan took over the company and initiated a brutal restructuring. They canceled planned factories in Europe, delayed construction in Ohio, and eliminated tens of thousands of jobs globally. Tan's mandate was direct. The deep cuts were presented as necessary surgery to strip away layers of corporate bureaucracy, empower actual engineers, and rebuild a technical workforce that had been hollowed out. A degraded corporate culture cannot be solved by lobbying for government grants or announcing ambitious roadmaps. Instead, it requires difficult operational surgery and a total overhaul of the internal values that the company rewards. The timeline of progress dictates its own terms. Apple did not wait for Intel to release a mobile chip before building the iPhone. TSMC and NVIDIA did not pause their development while Intel tried to fix its manufacturing bottlenecks. After operating for a half-century as the unquestioned heavyweight of Silicon Valley, Intel now faces a psychological test. The company has to drop its legacy assumptions, forget its former scale, and learn to operate with the desperate hunger of an underdog. No company is entitled to market dominance. The second an organization stops rigorously scrutinizing its own methods, a competitor is already assembling the tools required to dismantle it.